All right, hello everybody. Welcome to CS 202, the final class of the semester. Today we are going to go ahead and review stacks and queues. Like, we're going to look at the array implementation for the first maybe 10-20 minutes, and then the rest of the class we're just going to open it up for people that have questions for the exam. The exam has actually not been completed yet, and however, we know the topics and everything, so I can talk to you about that a little bit. But first, let's go ahead and do the stacks and queues so we can get that out of the way. Because it might, well, I'll guarantee you this: there will be a stacks and queue question in the test that will involve. Well, there might be more than one, but at least one of them will involve programming stacks and queues. So last time we went ahead and showed you how to do a stack and a queue using a linked list implementation, and that code has been posted as well. I encourage you to have that code available during the test, and then I will also do whatever I do today. I will upload as soon as the class ends as well. So let's go ahead and start. And by the way, redeem your extra credit points because today's the last day if you've been watching live. So okay, posted where? Oh my gosh, that's not a good thing to ask on the last day. Or it's the same place I've been posting it every single day since the beginning of the semester. On Canvas, there is a section where I have a link to the video lectures YouTube channel, like to my channel. And at the bottom, there's a link that says you can download all the examples that I do for the lecture here. And so you can check that out. And I'm hoping to, at some point, make that also in Google, like Google downloadable maybe at the end of the semester, so that I can share it with people that watch in future semesters, the video. But for you guys that are actually enrolled in the class, I've been updating it on the Canvas because it's very easy for me to upload. I just like literally refresh the file. But yeah, if you find a link for it, go ahead and post it from the Canvas. I think it's under like the first or second module on Canvas, where you have like other useful references, like for the notes and things like that. By the way, today's the last day if you would like to turn in your notes for extra credit. Well, not today, but like, this weekend, if you want, you can. But they have to be nice quality and readable. So yeah, it's somewhere in like the reference module. Yeah. Yep. Okay. So anyways, let's go ahead and get going because I want to get as quickly as possible through this so we have more time to review. And I do have the other class, so I can't go on forever. It is currently because people probably redeemed the maximum. Actually, no, it shouldn't be. It's maybe because you redeemed it too many times and you should have redeemed the 300 point. Just hang around until after the class and we'll redeem the points afterwards. Like when I end the video, so we're not just wasting time. Okay, so you should just hold on to the points. Yes, email's best. No Discord for that because I need to keep track of these things. Okay, so might help if we actually show you first. I like how I say we. I show you that how to actually implement a stack in an array format before we start even coding it. So with the linked list, that's easy. We just manipulate pointers. But the big limitation that we have when we're trying to implement a stack or a queue with an array is the fact that that arrays are fixed size. And so basically, that's going to be the first issue, that when the thing gets full, the stack or queue gets full, you have to resize. And that's going to it might not be as trivial as you think, because things might get messed up in the order. So you have to be careful about that. And then on the good side is that when you are inserting or deleting from something like a stack or push and pop, you can just keep an integer pointing to the index that is the most like the most recent thing that was added, so the top of the stack. And then you don't actually have to manually delete things from the stack. You just have to move that index around. So the way that actually works, and I'm going to show you first for the stack because that's easy, and then the queue involves a little more. So even if we don't do that, you will do that in 302. So remember how the stack works. You put something in the stack. What happens is, you throw it in there, and then you get something else in the stack. So let's say there's a B in there. And so you put it here. And so what you're looking at is the top of the stack, which is this right now. So if I was to put a third letter in like I did in the linked list, it goes here, but now the top of the stack is that. So if I pop something out, it would take something out of that. I would be actually taking out the last thing I put in, last in, first out. And then this would go down. Now, what is actually happening in the computer, though, when you take something out is you don't really take it out. You just kind of copy it out. So what you do is you add it to your output, and all you got to do is you move this index down one. So technically speaking, this is still in memory written like that, but it's no longer valid. So remember, when you delete something in a computer, you're not like erasing it or something. All you're doing is saying this is useless. Feel free to overwrite it if something else comes along, or it can just stay there. That's why it's a security risk if you're deleting something that you actually want to destroy. Like, I don't know, maybe you have a file with your bank account, and you're like, oh, let me delete this because that's my bank account number, and I'm in a guest computer, and you just hit delete. Well, if somebody really wants to, they might be able to, save that, especially if it's been very recent, because all you're doing is marking in the hard drive and saying, this file's, it's not, delete. So that basically means just mark it as empty space. And if nobody else goes in and overuses that space, which they might not, depending on how big the hard drive is, it's kind of random at that point, then it might stay there for a long time. It's like, think about it this way. If you left in your old house a gold coin, okay, and then you moved away, the next person that moves in might find that gold coin, but what could also happen is your whole house gets demolished to build like a skyscraper or something, right? So it's 50-50 there. They might find it. If they're malicious enough, then you can bet that they're going to go look in the house to see if there's anything of value. Or if they're not, then at some point it is just going to basically get demolished, right? So of course, people that are looking for things like this usually have bad intentions. So, but it could also be good. Like if you accidentally delete something, you can recover it. So anyways, that whole concept is not just related to files. It's the same thing that you're doing here. You're literally being part of the, I wouldn't say problem, but you're doing the same thing. I'm just saying here now that whatever I consider as a valid part of my stack is anything beneath the arrow, including what the arrow is pointing to. Although I could also configure this to have the arrow point to the next available spot, in which case I would point it to the C, but all it's saying is the next spot is here, not that this is the last valid thing. So both ways will work. I'm going to implement it today where the arrow is going to be pointing to, I would say the last item that's valid. So in this case like this, okay? So what I'm saying is if I go in and pop out another letter, I'm going to pop out a B, and I'm not really deleting it. All I'm doing is this. So now let's say that I push in something else. Let's push in a D in there. If I push in a D, that is going to go, first I'm going to have to increase this by 1, and then wherever this is pointing to is what I'm going to overwrite. So now is when I'm really overwriting this, and I'm actually putting in a D. This is like the demolishing part. D for demolish, I guess. All right. And then let's say that I go in and pop that. So if I pop it out, it adds it to the output here, and then this goes down 1. Okay. And now let's say I push in a T and an X. Okay, in that order. So first I push in the T, so this is going to increase by 1, and then this is going to be overwritten now. And then if I go in and push in the X now, this is going to go up by 1, and then the C is going to be overwritten. So notice how long the C was there for. It only got overwritten when I pushed 2 more things in. Otherwise, it could have been there for eternity. Yeah. Of course, this is being kept in main memory, so the moment you unplug your computer, that data is going to go away for the most part. Although, forensics, computer science forensics, if you shoot really cold air at or like just grab your RAM and dip it in like liquid nitrogen and freeze it, you might be able to recover the contents of your RAM, within a couple of hours after you turn it off. When normally it takes about 1 millisecond for it to go away, you can recover some stuff too. That's another cool thing that you can do if you're raiding in like some hacker's house and you want to get the information, and he just tries to like shut his computer down to erase everything in RAM. You just douse the thing in liquid nitrogen and you might be able to recover some things. That's for more advanced in this class, but basically you have to know how RAM works. RAM is something you learn in 219. I have videos on that, but I don't go even that in depth because that's more a forensics thing. But what you see is capacitors. You gotta know what a capacitor is, and RAM is made up of these capacitors, and capacitors have electricity in them. And if you turn something into a 1 because it's bytes, then you fill it with electricity, and that electricity kind of flows out slowly, which is why you gotta refresh it every 1 millisecond. I think it's every 1 or 10 milliseconds. I can't remember. But the point is that it's like a leaking tank. When your tank is full, that means it's a 1 in binary. If it's empty, it's a 0. But the tank leaks, and it's just impossible to stop the leak. So it's leaking slowly, so you got to kind of check it once in a while by dumping it and seeing what's inside and then refilling it. So when you turn off the computer, that process doesn't happen. However, you know, a leaking tank, when it finishes leaking out, there might still be a little bit left over for a little bit. Like the last bit of the leaking tank might take a long time to kind of leak out and dry out per se. That's what you can look at. You can look at very carefully and see, like, you know, this tank looks super dry, so it's probably a 0 when we rated the house. But this one has a little bit left over, so there's a high chance it was a 1. And then bam, that's how they catch the hacker. All right, so you'll learn all about this in 219, I hope. Or if not, then if you take a forensics course. So it's cool stuff. It is definitely cool stuff. Beyond my knowledge, by the way. By no means am I claiming to be good at that stuff at all. But that's pretty much what I told you is like the limit of my knowledge, I think, in forensics. But, okay. Let's see. It does sound pretty cool. All right, no more questions. Okay, so anyway, that is what we're gonna implement basically, okay? So let's just go ahead and jump in. And then the Q1, I'm probably not gonna implement. I'll just kind of tell you how it works. And then, you know, I'll leave it as an exercise if you wanna implement it, because that one takes a little bit longer. So yeah, let's just do this really, really fast. So we're gonna go ahead and make a stack class. And I think I have implementations of the queue and the array from last semester. No, from a year ago in Canvas. In fact, I have another link list implementation that I did a year ago as well. So you can also look at those and play with them. See the evolution of me coding the same thing a year ago from now, which I did not look at all at when I was actually coding the linked list. So maybe I made it better or worse. So, okay. So the only real thing that you want to have here, you want to make it dynamic because you want to be able to resize it. You could make it fixed, and that could work too. But you want to be able to kind of, you know, grow on demand. So you start out with a fixed size, and then you make it bigger if needed. But again, that's up to you. I'm just going to go ahead and do that. So that means I'm going to have a constructor and a destructor. And I would technically need to have a copy constructor, you know, rule of tree and everything, assignment operator. I'm not going to do that. There's not enough time. So, you know, that means don't try to like copy our stack into another one, which would make resizing it like piece of cake actually. But we won't do that. So, okay. So the Lord, you're going to make everything public just to expedite things as well. And the only real local variables that you need is an integer. We're going to call that top, which is going to be the arrow that's pointing to where the last valid item is. And then I'm going to make it, I guess, a stack of integers. And I could have made it templated, but I'll make them integers this time. We did cars last time, so for variation. And then I'm going to go ahead and make a pointer of the actual array that I'm storing. So I'm going to call that, actually, should I call that array or stack? I'll just call it A for making things faster to code, okay? So let's go ahead and pick a fixed size to start off with. So I'm just going to go ahead and make a stack that can hold 4 items. And so what I'll do is I'll make this be a parameter here, which will be the size. And I'll make it a default one that's set to 4. And then I'm going to initialize the top variable to point to 0 because it's always going to be pointing. Actually, if I wanted to point to the first valid item, then I have to initialize it to -1 because when the thing is empty, if I pop this thing open again, you know, when it's empty, it's always pointing to to a valid item, right? So right now it's actually all the way full. But if it's empty, then technically this will be pointing down here. So -1 is going to indicate an empty stack. Okay, so I'm going to initialize the top to -1, and then I'm going to unless, of course, no, it's always going to be initialized to -1. I should store one more variable here. Actually, that's the size of this thing. Yeah, that could be useful. And so I'm going to set that size to whatever the parameter that I'm passing in is. So it's S. And then I'm going to dynamically allocate an array of that size. So I'm going to say A gets new int and then of size, which at this point has been initialized. You could also do S, doesn't really matter. Okay, so that creates the array, and then just, you know, memory leaks, might as well delete it now. So I'm going to say delete A. That takes care of deleting that. Okay, I don't need to set it to null because I mean, it's going to go out of scope anyways. Okay, so that's just the basic stuff with dynamic allocation, although good review for the test. So we did that. And then now we're going to have to implement our push and pop. So push is a function that requires a parameter, which is the data item that we're pushing into the stack. And then pop's a value returning function that returns whatever we are popping from the stack. So something like that. And I'm just going to make them inline in this case, again, just to speed up coding. So, come on. Okay. So in this case, when I'm pushing, first thing I want to check before I do anything is probably if I'm out of space, right? Because if I am, I'm going to have to resize it. For now, I'm just going to give out an error, okay? So the way I can check that is I can see where the top is pointing to in relation to where the size is. So if the size of the thing was 1, if you could only keep one item in the stack, then if we have something pointed at index 0, then the thing is full. So basically, I want to say that if the top plus 1 is equal to the size, then that means that, or greater than, I suppose, just in case you do some weird thing, then it's full. And then I want to resize at this point. So I would say error stack is full. Okay, for now, and then maybe we'll go back and edit this to do the resizing. Okay, and then for now I'm just going to return in that case. Now if it is not full, then it's as simple as saying a.top is plus 1 is where it's going to go, right? Because top is pointing to the latest valid item, and if it's empty, that's -1, with -1 plus 1 is 0, which would be the first valid spot. So you can just go ahead and say D gets stored there. You do need to increase top after that, so you can do top plus plus. You could also be fancy and do this all in a single line of code, actually, in here by using pre and post increment and things like that. So you could do something like plus plus top, and then you're good to go. So that could work too. Make sure you don't do top plus plus in here, because otherwise you're going to get the old value of top before you do the increment, which is a bad thing, because you want to increment it first and then put the thing in there. So there we go. That's pretty much it for the push. For the pop is the reverse of that. What we want to do is let's just create a temporary variable for what we're going to return, or we can just do everything in a single line of code, but I'd rather do it in multiple lines so you can see better. So first we're going to say int answer. And what we're going to store in this int answer is basically going to be what's in the top. And after we go ahead and we store that, they want to decrease top by 1. So we can do top minus minus. Yet again, we can combine these two lines and say something like top here minus minus. Now, in this case, I do want to use post decrement, because what I want to do is I want to access a top. So the index at top. After I access it, then I want to decrement it. So this is where you want to use post, because I'm going to get the old value of top and then I'm going to decrement it. If I did pre-decrement here, I would first subtract it and then access that index, which is not what I want. So that's the good one. So in fact, I could go ahead and even now make like easy by saying return. Okay, bam, single line of code. However, I do want to I do want to have an if statement here just to be extra safe, and that is, what if the stack is empty? I don't want to access in -1 of the index, right? That would be really, really bad. So if top is basically less than 0, then that means the stack is empty. So you don't want to pop in this case. So again, you want to say some kind of error saying error stack is empty. And this one, there's no recovery from. I mean, if you call this an empty stack, bad things. So you still got to return something because it's a valid returning function. I mean, you would throw an exception here if you do anything with exception handling. For now, we're just going to say it's going to return like -1 or something. And then it's not going to decrease the top. Okay? So that's it. That's pretty much the implementation of this. So we can go ahead and test it by, we can maybe copy the code from this one. I don't know, because we call that insert instead of push or something. Or here we go, stack push. So we might be able to just copy some of this code over and use it here. So we make a stack, yep, stack push, and then just replace these with numbers. I mean, you could actually leave them like this because this is really just a number, but I'm going to go ahead and replace them with actual numbers so you can see it better. So, oh, we do need a print function if we want to see what's in the stack, but Yeah, sure, we can go that really fast. Why not? And then stack pop is all good to go. Yep, 4 of them so we can see the error. And then maybe we try to push a little bit too much in the stack so that you can see that that error of the stack being full. Okay, so let's just code the print function really fast. So that is just going to be void print, and then for int I is equal to 0, I is less than size, I plus plus, cout a sub I, and then let's put a space in between them, and then at the end of the loop, let's go ahead and put an end line. Maybe we'll put something like list or stack contents, cout stack contents. Okay, so as long as this compiles, I think it's good to go. Do you need a parameter for the constructor? I don't, because I'm using a default. So I'm using the default size to be 4. If I wanted to make it like 3 or something, then I can change it. We'll test that in a minute too as well. But yeah, good check though. Good check. All right. So let's go ahead and try to compile it. So this is actually called more.cpp. Error, stack is full. Okay, yeah, it worked. That's actually what we wanted to see. Because here's the thing. We're pushing in 1, 2, 3, 4, and then when the 5 is trying to be pushed, that's when we get the error. As you can see, the stack contents are only showing 1 to 4 because, again, the 5 didn't fit. Again, we would have to make the resize function. And then you can see that when we pop things out of the stack, they are coming out in the reverse order that we push them in, because that's how stacks work. So yeah, stack is working. We are in business. Last thing to do is the resize function. So the resize function in the case of the stack can be as trivial as just copying things over with a bigger size and then keeping the top be the same. That's not painful. It's painful when you do the queues. So we're going to say void resize. And this time, instead of this being an error, we're going to say a warning, I suppose. And then instead of just returning, we are simply going to call resize on ourselves. Can we do that? We should be able to do that. Yeah, that should work. I don't even think we need this pointer. Yeah. But okay. I'll leave it in there anyways to make it clear that we are resizing ourselves. And then after we finish resizing, then we can basically do the insert as normal. So no return statement there. So now for the resize, what we're going to do is we are going to have to make a new array. So int temp equals int new int, and then the array. Let's say you're just going to double the size of the current array. So we're going to say size times 2. So we just made a bigger array. Now let's go ahead and copy everything over to the new array from the old one. So I is less than size, which is the size of the old array. And then we can go ahead and say temp sub I is equal to a sub I, which is the old array, right? It's a or AR? Yeah, it's a. Okay. So after that, now we need to go ahead and delete the old array. So we can say delete a. And then what we want to do, this is the little kind of neat thing, is we are just going to make that pointer point to the pointer of temp. What this is doing is basically, if I draw what's happening here, what I've done is the following. So I have my object, which is the stack object, right? And in that object, I have a couple of variables. I have size, I have top, and then I have the pointer A. And the A is just a pointer to somewhere in main memory where I have the actual array. What I'm doing is I am making a temporary array. So I'm saying I'm making temp, and then I'm making it to be a bigger array. So I guess for scaling purposes, let's make this a little smaller. So maybe this is this big, and so this one's twice as big. Okay, so first I make those two arrays. Then what I do is I basically use the loop to copy everything from here to here. So I'll take that and copy it here. After I finish copying, what I'm doing is I'm saying, okay, the allocate this array, and then make the pointer, instead of pointing to the old array, go ahead and make it point to what temp is pointing to, which is the new array. Okay? So now, basically, I have a bigger array. So it's a little fancy, but that's all I gotta do. So you gotta make sure you gotta delete the old one, otherwise you got memory leaks going down. Okay? And then the size should get updated. Don't forget that. So now I'm gonna go ahead and update the size of the array, because the size is still pointing to the old size, but the size is now twice the size. Okay? The top doesn't need to be changed. That can stay the same. So yes, I'm glad I remember that one. Otherwise, weird things could happen on the print. But anyways, if we do that now, you can see here that we do get the warning that the stack is full, but then internally there's resizing going on. In fact, if I go ahead and write a cout statement here saying resizing to, and then maybe do like size times 2 so you can see that, then you can see that it says resizing to 8. And then I do the print, so you can see now that the stack contains everything from 1 to 5. So that means that, yes, you can see we oh, hold on, my bad, apologies, you can't see that. Okay, there we go. So as you can see here in the oh, you're seeing me, not the thing. There we go. So as you can see, before we were only able to store 1 through 4, but now instead of getting an error, we get a warning, and then it resizes the stack to 8. And as you can see now, we are able to store the 5, where before we couldn't. Now you see these 3 other zeros. That's just because when we made the array bigger, in this case we got lucky and they got initialized to zeros. Don't ever trust that. That's just garbage values technically. But that's why when we do the print, it's printing out the full array. So that's why those are there. But when we pop things out, you can see that we're getting 5, 4, 3, 2, and there's still something left in the stack because we only did 4 pops actually. So if we do one more pop, we'll see the 1 come out. There you go. Okay, so that's how you resize a stack essentially. It's not that bad. Now for the queue, it's a whole different story, because the issue that you have with the queue, and I'm only going to go over this for like 5 minutes and then we're going to move on to the review, is the thing with the queue is that you have a front and a back. So this is like the wrong way of doing this. If let's say that you start, you keep that same mentality of like the top being the front of the queue. Okay. So like, let's say you enqueue some things, and as you enqueue, you kind of keep another index point. It's not a pointer, it's just an index, but I call it pointer. You have it kind of a little pointer here that's pointing to the last item in the queue. So if you insert something else, you just move it forward, and you kind of keep doing this, okay? But then you dequeue something. But the thing is, you dequeue from the back, right? So we're gonna keep another index that's just going to be called back. And then if you want to dequeue, what you do is you basically take that out and then +1 this, right? So you can use the same system as the top, but in the back of the thing to keep track of where the back is. The problem with doing this is as you enqueue a bunch of things, so let's say we enqueue a bunch of 1s. This goes all the way here. And then let's say that we dequeue a couple of things. So we dequeue this, this, and this. So then this one gets moved here. The problem with that is that what happens when we run out of space here? So like we enqueue, bam, that's it. That's all we can enqueue because we are out of space in the array before we resize. But here's the thing. We got a bunch of empty space here. I know, this, I technically erase the numbers, but there's still numbers in there. They're just marked as deleted. But the point is that we still have that space available. So it's being wasted. And if we resize, then, we didn't have to. We had space. So what you need to do is you need to do a wraparound. So when you run out of space here, then you want to move this here so that you can keep inserting it. And only when these two crisscross front and back is the sign that you're actually full. Whether they crisscross this way, or if they crisscross this way, then it means that it's empty if they both point to the same thing, if it's coming from this direction, okay? Doing this circular stuff seems complicated, but it's not complicated. It's rather trivial actually once you think about it, because all you got to do is use modulus for the size of the array, or just check the size and see if it's greater than the size and subtract the size from it, which is what modulus would do. And then if you do this, then this is known as a circular array queue, and that's the best way to implement a queue with an array. You still have the limitation about getting full when things first cross. And then when you do that and you resize, that is not as easy as just copying the array over, because things can go wrong pretty quickly with that because of the way that it's set up. Like if you copy it over, then you might get a bigger array that like goes here, but then this part's supposed to go before this part because of the circular stuff. It messes things up. So for that one, you gotta basically dequeue everything and then queue it again to make sure you don't screw up the order of the queue. So there's a little bit more effort to being able to resize a queue. But you'll learn about this in 302, so I'm not too worried about not showing it to you today. Okay? I just want you to be aware of that implementation. Of course, if they ask you in the exam to implement some sort of queue, then I would go with the linked list approach because solves any of these issues. So yep. Okay. So that pretty much concludes all of the material for the semester. So congratulations, you have finished. Well, you have finished the lectures for 202. You haven't finished the class yet because you still have to take the final. And so the final is going to be next Tuesday, so a week from yesterday. And I think it's from 1 to 3 p.m., but you can double check that on my UNLB's, or no, just the UNLB website. And I will, of course, also when I post the test, it'll say the time it's available, which will be, I think, from like 1 to 3, but just double check that. Don't quote me on that. Yeah, 1 to 3. Okay. All right. So there you go. So it is indeed 1 to 3. That's what I thought, but I wasn't like 100% sure. Okay, cool. So yeah, so just it will be available then, and then you'll have the full 2 hours to do it. So it will be probably longer than your regular exams, and it'll be comprehensive, and it will be some coding and some questions, just like before, with the question sets and whatnot. And yeah, by the way, I just remembered, if you lost points for a double linked list question or anything, make sure you let the TA know so you get points back for that, or if you think you lost points. I think I told him, but it might be good to remind him about that. But okay, so I am opening the floor now for questions on what you want to ask or review for this exam. So does anybody have any questions about anything in particular? Now, that it can be pretty much anything in the course is fair game for the exam. So yes, anything. We have basically 45 minutes, give or take 4 minutes, to do this. So are there any things in particular that you want me to go over? I'll tell you that the test will involve, will bias towards the latter content of the course. So you can expect dynamic memory stuff, you can expect linked lists, you can expect stacks or queue question, recursion. However, there will be definitely questions about virtuals and inheritance and other things, but it won't just be as heavily focused. So yes, go ahead, that's fine. I will just chill here. In the meantime, please, if you redeemed extra credit, message me on Discord or send me an email so that I can claim it, so that I can clean the queue, I suppose, of rewards. And let me see why I keep saying it's out of stock. Try to do the redemptions again and see if they work now with the cooldown. I guess it worked. I see people claiming stuff. There's also a 50.1 too. How are the specifics going to be for the programming questions on the exam? So since we have not decided the programming questions yet, I can't tell you more specifics than that, but let me tell you the questions that I'm going to put in the test that can potentially come to you. I would definitely have a question about implementing a stack or a queue and giving the option to implement it in whatever way you want. So I'll be like, write a program that can flip the input backwards using a stack, and called the stack. You can choose to do the linked list, or you can choose to do the array one. It's up to you. So you can expect a question like that. If you're from another university, then welcome. We are reviewing for their final exam, which is 202 Object-Oriented Programming. Why is the header file known as the interface file? That's a very peculiar thing. I don't think that we're going to ask you any questions about multi-file compilation. Interface file. You know, well, here, let's talk about what the header file does, and then from there, maybe go from there. So, typically, when you're compiling a program, you are working with. Well, yeah, but that was because it was picky back then, I suppose. So when you're working with a program, you know, and this object-oriented programming, so you have a class, and then you have all of your function names and variable names and everything. So you have your function declarations per se, and variable declarations, and you have your class declaration. This you typically keep in what will be the header file, and then when you're actually implementing all of the functions that are inside of this, so, you know, if you have a function print and you want to actually write the body of the function, then you would do that in a C++ file. Now, by convention, you would name this header file. If the class is stack, then you can call this like stack.h and stack.cpp. From there, you may also have a main.cpp, well, you probably will, and then there you would have the actual function calls / declaring an object of the class that you just made here. So that's kind of the 3-1. So as for why you'd call it interface, you know, that's tricky. So I don't know what they meant when they asked that. I'll have to check with them. Did you get it right? I guess is the real question. Interface header file. I don't know. See what Stack Overflow people say. You know, maybe they're thinking of Java. That's true, because in Java you have interfaces. And that's good that you call it implementation, because that's kind of the correct way to think about it. You're implementing what you just basically declared. So, yeah, that's a good answer. Write a program that manages a train. A train consists of cars, and there are 3 types of cars. Control passengers and cargoes. Isn't that what the assignment was for that you guys were doing with trains? That manages a train. The control car comes always first in the train. I would do a linked list for that. Obviously, I can't see what figure you're drawing. But I would make, okay, so what I would do there is I would make a class called train type. And then I would inherit that class. I would do all the common things that the train has, and then I would do inheritance from that. And I would inherit and make 3 child classes called control, passenger, and cargo. And then from there, I would go ahead and put those in as nodes of a linked list, which would then have the insert function do all those checks about which type of train can go before other types of train. That's how I would approach that problem. Of course, it's up to you to figure out the details, because otherwise it would be cheating to tell you specifics. But that's my advice for that problem. Can a friend function access private members? Yes, it can. So friend functions allow you to access private variables of the classes they are friends with. So if let's say that we have a class train, I guess, and somebody said trains. So let's say we have a class train, and this class train has a private variable that is like the size of the train or something, okay? So if I want to have a function void foo that is a global function but can access that private variable, you know, let's say that actually here, just to make it more useful, let's say that we are calling the function and there's a parameter train t in here. So if I want to see out for some reason in foo the size of the train, like such, then this will not compile because you're accessing a private variable. So what you would do is you would add to this kind of like a, doesn't matter if it's private or public, by the way, the friend, but you would add here friend, and then you would say void foo, the same signature and everything, train T. And now this will compile and be able to access that. Oh, I don't know. That seems like something was rated wrong then. You should tell me about that so you get points back on that. Maybe the true false thing was like marked wrong when they made that question. You redeemed extra credit, then message me on Discord who you are so that you can get the points. Can we use 2 different class names in one class? Can we use 2 different classes names in one class? Well, when you declare a class, that name is unique. What you might be thinking of is inheritance. When you're doing inheritance, you say something like this. So like if you're inheriting passenger, the train class, you say something like class passengers colon public train. This would be inheritance right here. You can do multiple inheritance by putting a comma between each of the inheritances. Like public, I don't know, boat. Let's say that's another class that you're inheriting. So that's maybe what you're talking about. Okay? Class B. Well, you can have multiple classes in your program, but they all have to be separated. So at the end of each class, when you put the curly braces, you put a semicolon and then you make another class. You can have as many classes as you want in your program. But it looks like you're thinking Java, the way you're writing that, with the public class thing on the top. This is C++. I was awarded points, but the answer stated was friend functions are non-member functions, and so cannot access the private unprotected data members directly, whereas member functions can directly access it. I'd have to see how the question is asked, but I would disagree with their explanation for that. I was awarded points, but yeah. I mean, friend functions, by the way, friend functions, okay, sure, they're non-member functions, sure, otherwise you wouldn't need them to be friend functions. But the whole point is that because they're friend functions, they can access privates. You can do it. Otherwise, you would not be able to overload some things like insertion and extraction, right? Directly. I don't know. I think that's a poorly written question. I have an idea on who probably did that question. I don't want to talk crap about anybody though. But we'll give you points back for that. Just tell the TA and then tell the TA to ask me if he doesn't trust you, and then we'll give you points back on that question. And then I'm gonna actually find out and yell at the person that wrote that question. Again. Because that's kind of really poorly written. You know, this is the thing that we missed out. When we normally give out a test, what I do is when you get the test back in person, I have a review day where I go over the answers and things like that. And then I stay after class, and then people come to me and kind of debate with me if they think something was right or wrong, and then I can see that. And then this is when we discover these kind of things. Unfortunately, with the remote, we don't really have that experience of being able to do that. I've had to stay like half an hour at some point. Like I've had lines of like 15 people for a question or something. Yeah, sometimes we have to even walk to my office afterwards because there's a class afterwards, 15 minutes later. So yeah, we kind of missed out on that experience. I'm not complaining though. I mean, it's kind of intense having to look at all those things, but yeah, you kind of miss out on that experience of being able to contest things. But you can still contest them. You just have to kind of be more proactive about it instead of just me being there available. It sucks, but that's the life we're living in. Oh, we should do, that's right, we were going to go over the ABET. We should do that. If somebody has more questions, let's see. Let me read what you guys wrote, and then we could go over the ABET. There was a question on the ABET where assign an address to a pointer using. Okay, we'll look over the ABET. If A is an int pointer and B is an B, it's a picture. I can't see what's going on. Okay. So we're University of Nevada, Las Vegas. Okay. Let me make the ABET public so you can see the answers. And then we can go over the question you're talking about or any others that you guys might be stuck on. So it should have made public, but let me see. Let students see their quiz responses. Let students see the correct answers. And then hide the correct answers tonight at midnight. How about that? So you have until midnight to see them. But you can see them now as well. Okay. Yes, doubling this question will be on the exam. It will be indeed. Okay, I made it public so you can see the answers now. Now I'm going to go ahead and kind of look at the answers too and see what you guys were talking about. Okay, so like for example, choose the correct comparison between structs and classes. I mean, I hope you guys know that one. I'm assuming it has to do with privates, right? I think I made this ABET for everybody like a year ago. I don't remember. They might have been modified since I made it though. But okay, so now let me look at the question you were talking about. A and B as a pointer. So, oh, I forgot I had that one. Oh, I love that question on the ABET with the. I hope you guys got this one right. So the question that's asking something like, let me copy it here. X is equal to. This is my favorite question, all-time favorite. It says rewrite it using the arrow operator. So it's my dog like running around. Okay. So yeah, that's a good one. And then looking for the one that you mentioned with A and B. I can't find the one that you're talking about. Mine still says muted. Oh, hold on a second. I know what I have to do as well. Just give me a sec. We have to put in to unhide it. Okay, I see it now. So I'm gonna click here. Post grades, everyone. Give it like 30 seconds and refresh. In fact, try refreshing now. Don't DDoS it by having everybody refresh at once though. But yes, refresh it. Okay. So I'm looking at the grades though. I mean, people got zeros who didn't do it, but the ones that did do it, most people seem to have gotten about 15, 16 average, I would say. Maybe like a 15 average. That's not bad. That's passing. Okay, so let me see if I can find the one you're talking about. Oh, I think I know what you were talking about. Is it the one that's asking what is the output after the code executes? Maybe I can write it here. So it's something like int p1 x1 equals 42. P1 is equal to what the heck is that slash there? That slash should not be there, probably. I don't know what that slash will do when you run the code. I don't feel like that's not gonna compile at all. I feel like somebody took my latex code and just flat out copy and pasted it. Because in latex, you need to put a backslash before you put the ampersands, so that the code can be built in latex. So I bet you that's where that came from. Yeah, that's good. Yeah. See, so the test that I made was a printed test, and I make it using the latex program. It's like a really fancy version of Microsoft Word, and ampersands they're taking like, it's like HTML. So you gotta some things are taken as like tokens. So to not make it taken like a special token, you put a backslash in front of it. But the backslash doesn't show up when you print it out. It just shows up on the latex source code. So they just probably took the latex source code and copied and pasted it. So I'm glad you guys took that out. So yes, okay. So let's look at this one first, I suppose. So we have a pointer and we have a variable, and the pointer is not initialized to anything. So what we're doing here is we're making the pointer point to the variable, because the address of is going to get us the address of where this variable lives. So if we kind of draw the little memory thing, let's just say that this is address 0x100, and of course this is in hexadecimal, and this is where 42 lives, okay? And then somewhere else in memory we have a static variable as well, which is the pointer. That pointer right now is just pointing to who knows what. But when we go ahead and run this line of code here, what we're saying is make this point here, which means copy address 0x100 here. Okay, so now we got them pointing to each other, essentially. Okay, from there, and I wrote this, but I have to look at it because I don't remember. So we are dereferencing the pointer, right? So in here we have a dereference. So we're saying whatever P1 is pointing to, which we, by dereferencing saying 42, increase that by 1. So this is saying increase 42 by 1. Do you guys see that? So basically, this is in parentheses, so it takes precedence. So we're saying dereference this address. So instead of being 0x100, the dereferencing makes it 42. And then plus plus makes that, or sorry, I said 43, not 41. I subtracted it. My apologies. But yes, increase that, 43. Next from there, we are saying, okay, take value of x1 and add 42 to it. So the value of x1 is right now is 43, right? Because it's x1. So we're gonna add 2 to that. That's gonna make it 45, and then we're storing that back in there. So now we have a 45 in here after running this line of code. And then after that, it's just couting basically. We're couting C that without the quotes, and then 45 plus in line feed. So yes, now the slash was weird. Answer 42 says the P1 should get a valid memory address from address. Well, it wouldn't compile at all in that case. So don't feel bad if you got that wrong, but I will definitely put that in the report for the ABIT that more than likely people got that wrong because the slash was there. So I actually add that in the report. So yeah. If we didn't have the parentheses for the asterisk P, we would be incrementing the address, right? Yes, correct. So if alternate universe, you had the following line of code that said that I do believe that this takes precedence over the dereferencing. So you would be incrementing the address and then trying to dereference that. So you would be essentially dereferencing address 0x104, not 101, but 104 because of the way that the because it's an pointer arithmetics work, right? Pointer arithmetics, you don't increase by single values, you increase by the size of the pointer. So in this case, it's the size of 4. So, well, assuming that this is case of 4, which should be, but you know, it's possible that the computer could have a different size of an integer. So yes, you would be basically trying to see out whatever is here, which would be some garbage. So you would basically just not see out; it would just kind of be disappeared in memory. Yeah, bad things would happen if you did that. So bad things would happen. The question with the rec function was missing a parenthesis so it wouldn't compile. Oh my gosh. I trusted them to copy and paste this digitally. And I mean, they gave this. So when I made this test was in the fall of 2019, which was the last time that I taught 202 before the summer, which we don't do even in the summer. So I made a printed version. I gave them that. They made a Canvas version for last semester. People took the test. I would assume people would have complained that these things were wrong, but they didn't fix it. So, yeah, I see it's missing a parentheses. How did they miss that one though? That's just, I don't know. Shake my head with that. So I'll have to write those two things down. Parentheses, backslash. So yeah, shake my head on that. What are the appropriate steps in order to create a program next to you from source code? That one looks like a new question because I don't remember asking that. You sure that was in the test? Oh, I see it. So the answer was compile, link, and execute. That is technically correct. It's because what happens is things come. I mean, well, yeah, because you compile. You can. I mean, it's debatable, but like they are not wrong in the sense that when you compile something, you make an object file, and then you link those object files to execute. Compile, debug, link, execute. Was that a question? Was that one of them? Oh, that's funny. I don't think that's a question that I wrote, actually. That's a new question. But, I mean, that's assuming that, like, I mean, remember, this thing doesn't count for your grade. So if you got them wrong, don't feel bad. Like, you only get a completion grade for this. You're all going to get the same grade. But, so don't feel bad if you got that wrong, I suppose, in theory. But I guess debug is more of like an optional thing. If you write perfect code, then I guess it wouldn't be wrong. I can definitely see how we never really talked about the linker in this class. It's more of a 135 thing. But the linker is what puts multiple files together when you run them. So, and what's happening is you make an object file when you compile like a header file. And then you link those object files together. As an example, when you're using a library like vectors or STL stuff, you are technically compiling your code and linking those calls to those libraries, and then you have the code ready to go. When you get those weird errors that are like, I'm sure you've seen before, where like they're not color coded or anything, and it's just multiple function names in a row. Those are linker errors, which happen after the code would have otherwise compiled. So, yeah. Like, I think I might be able to replicate those errors if I use like an extern. So if I say like extern void foo, and then I say foo, and I compile this. Let me switch over to the. So if I do something like this kind of error is what I'm talking about. So you can see here that this is making a temporary object file, which is for the main. And then when it goes to try to link it to foo, it's like there's no foo, and then the error is out. This is a linker error, not a compiling error. And I'm sure you've seen these weird errors like this before. In this case, it's because I'm saying the foo is found somewhere else, which I promised the computer I would compile, but I would link, but I never did. Was there a textbook for this class available somewhere? So not really. Like, there was a recommended book, which was a DS Malik book. And then there's another one that's a free online book that we found, but I'm not too happy about it, and we're not really going to use it again. We are in the process trying to make our own book, like an open source Wikimedia book. But that's going to take years, probably. So, yeah. But hey, it will be made. And yeah. But I mean, all the test stuff is going to come from the lectures, at least for my test. So, hey, but it's kind of weird. But I'm glad you guys tell me about that, because I can definitely say something about the linker stuff. Like, maybe I should add it to the report that I should talk about the linker next semester or something. It gives me stuff to write about. That's good. Anyways, we didn't go over this question, though. Did you guys get this one right? I will be proud, because I do feel like people struggle with this question, especially other sections that don't take me, because I feel like they don't go over pointer stuff enough. But can you, or did you, figure this out? So this is kind of like a inception. You got to work your way in from the deeper to the outer levels here. So we got the deepest set of parentheses are these. And then the next set of parentheses from there are these. And then, well, are we missing? I forgot a copy of parentheses here. Oh, no, I did not. So actually, I did not draw this, right? There we go. That's better. So what you got to do here is you got to dereference the A before you go to the B. So that becomes that. And then you're basically doing the exact same thing again to get that. Oh, you can't see what I'm drawing. My apologies. There we go. So that one. So This question was, that's my favorite question of the test, of the ABET test, that I did write this one. And so again, you start out by looking at the parentheses and kind of work your way there. So what we're saying is we want to dereference before we use the member access operator. So that becomes AB. And then you got to dereference again before you do the member access operator here, which means another arrow C, like that. Yep. So yes, that was a fun question. Did I miss anybody's question? I don't think I did, but yes. So you have not anything you want to ask for anything? Any other questions from the ABET that you want me to go over the answer as well? I mean, you recently had the other test, so hopefully you don't have to worry too much about refreshing that content, unless you got something wrong and then you know you can focus on that. Okay, feel free to ask it outside of the ABET, that's fine. Only one of the answers used two of the arrow operators, so there wasn't much to choose from. Yeah, I should have made more arrows everywhere. Feel free to ask anything, even not in the ABET. We still got 15 minutes approximately. We only need destructors if we allocate memory in the class. Yes, I would say that 99.9% of the time that's the answer. You can use a destructor for something else. Like one of the assignments that I had last year that I made, I actually used a destructor to close a file. I used a constructor to open a file with file streams and then close it with a destructor. It was a little fancy thing. I thought it was frankly the only thing I could think about for using a destructor without doing memory allocation. And so I actually just flat out just did that. But from a practical point of view, then yes, you are indeed correct. Only time you need it is when you need to deallocate memory to avoid memory leaks. Describe the difference between a dynamic array and a linked list in terms of memory organization for both of these structures. So what memory organization is talking about is whenever I do those rectangles, like this stuff. And so an array is going to have a contiguous block of memory. It's a good word to remember. I don't know if I can spell it, but contiguo, something like that. Block of memory. What that means is that all the members are pretty much next to each other. So that's why you can use pointer arithmetic to go very quickly, anywhere in the array. That makes things fast for accessing. A linked list, on the other hand, is going to be all over the place. Like you might have a node there, and then a node here, and then a node here, and then like a node here. So this could be the first, second, third, and fourth. So it can be all over the place. That's why it's slow and you can't access it quickly. So I think that was basically what they were going for. That arrays are just one nice little block of memory. Pointer arithmetics can be used. And then this one, it's all over the place. So it's a little bit more messy. There's no specified order, no required order either. So that screws access time. So yes. Yep. Hope you guys can hear my dad's playing with my dog. Other questions? All right then. Or save your thinking for when you have to do the exam too. Yes, there will be a double linked list question on the final. So yes, you can expect doubly linked list question. Yes, I cannot write today. If you have not redeemed points, then make sure you redeem them. Today is the last day to redeem points. You know, I'm trying to think of something that would be something like, oh, you know, you probably forgot about this already because we talked about it such a long time ago. You know, one of those things that you don't use a lot, but maybe you want to refresh could be operator overloading, templates. Well, templates we've been using quite a bit, I think. But yeah. Well, the posture check doesn't give you any extra credit points. You might as well save those for real points. Oh, well, then again, if you have that very little points, you probably won't make it to the other one. No, that's pretty short from anything. It would be like 20 something points. So I guess in that case, then that's about 2 hours worth of lecture, or maybe 1 hour. I don't remember. So no, there is not much you can do with it. Oh yeah, you can do the sub emotes. Well, I'll still just kind of idle here for a bit in case there are more questions. What I'll do, how about this? I'm going to end the video recording, and then from there I will just kind of stay online and start redeeming points, I suppose. That way, and then if somebody else has a question, then you can ask it. So I can start redeeming it, so that if there's any issues, then we can handle those. Okay? Oh, we have to hydrate, so I guess I'll hydrate. But yeah. Well, since not everybody's here, though, I would like to take a moment to say goodbye for those that are watching on YouTube, but also for everybody in general. Fun class, fun times, challenging, I suppose, for all of us, but we got through it, and or at least we think we'll get through it. There is the SU system, so if you're really struggling, then that is a chance, because for the SU system you only need a D- to pass with an S, whereas normally you would require to have a C or better to pass. So if you're in that D range, or you might hit that D range, then you know there is still a chance, as long as you don't go to the F range, to pass the class with the SU system. Of course, hopefully none of you are in that situation and you're all at the high points. So yes, but yeah, make that a decision if you think that you might be better off switching to an S. Even if you have like a B-, you know, you might want to just do S so it doesn't lower your GPA, if it would lower your GPA, right? I would not do it if I had like a B+ or A, because that's really high, and you might as well do like, you know, like think about it. Might be easier to get these in like the higher division classes to get a high grade. So that will be a choice you have to make. If you have an A, then there's no reason to make it an S at that point, because that's bad. You want to average high. So yes, but anyways, for those watching, thank you all, and good luck in your future semesters. Good luck in life. Stay safe, everybody. So yes, and you know, stop by some time in my office once we go back to normality. Be nice to meet some of you who like I have not otherwise seen, because there's a lot of people here now. Like in the summer, yeah, even in the summer there was, and it's strange because I only know you by name, but I'm like a face associated with it. So it's kind of a very, very strange thing. So yes, thank you all for that. All right, I'm going to end the video and I'll start doing the redemptions.